Okay, thanks for having me at this Virtual ConnecTechAsia. My name is Kieran Kunhya, and I'm going to be talking about satellite replacement / augmentation for broadcast contribution feeds. So yeah, who are we? Open Broadcast Systems is a company specializing in software-based encoders and decoders for sport, news, and channel contribution. As I kind of explained a few times, this is B2B, and we're heavily focused on IP video. We're based in central London, so just to my left is Big Ben. What's also important is we're not to be confused with the other OBS, Open Broadcaster software. Unusually for a broadcast manufacturer, we have a small side business on our roof above me where we downlink feeds and transport them using IP around the world. And this gives us a lot of insight into the differences between satellite and IP technology. This is often being able to transport feeds to areas outside the footprint. So in Europe, this satellite footprint, so this in Europe is places like Iceland, Sweden. And we can also deal with high-end feeds, including Novelsat feeds with an S3 and an S4 technology. In particular, we use the public internet to transport video, and we use various different types of packet recovery technology. And unsurprisingly, it's use of our decoder product at the remote end. So what should we cover? And we'll cover the current state of play between IP and satellite. We'll look at the business benefits of satellite replacement and augmentation. We'll look at the technical benefits of doing so. And unsurprisingly, there's going to be a COVID angle to all of this. So let's introduce the field. What is contribution and what is primary distribution? And this great graphic here from Media Atmos shows this really well. Contribution, generally speaking, is, again, B2B transport from somewhere like a venue or a stadium or an event, or where an event takes place, or sometimes between broadcasters. Usually content that hasn't quite been finished yet. And primary distribution is the delivery of, say, a final channel or final piece of content to a broadcaster or a cable operator. So this means it hasn't yet hit the consumer's home, but it's a B2B service generally. So what are the advantages of satellite? Many advantages. In particular, there's a wide reach, as you can see in the footprint to the right. Many countries can be hit with a single uplink. It's got really high reliability. It's not that easy to dig up a satellite. There's expertise in most countries. There's SNG vehicles, there's fixed uplinks. And importantly as well, you can uplink from pretty much anywhere. Doesn't matter if you're literally in a field with zero connectivity. There is the ability to uplink. But satellite comes with a lot of disadvantages. It requires a lot of physical maintenance. And this is quite tricky when quite a lot of us are working from home right now. If you look to my right, that's literally corrosion on one of our antenna cables last week as a result of bad weather. And this needed a team of people to climb onto a roof and physically fix it. Satellite capacity is shared. It needs some form of booking usually. It's affected by weather, so there's rain fade. Often quite specialist and sometimes unwieldy equipment is needed, antenna controllers, etc. You've got to send signals into space, so there's at least roughly 1 second, half a second of latency. Usually it's one-way traffic. For long distances, multi-hop links are required on, let's say, Australia to London. And today, many takers of sports are actually OTT platforms who don't really want to operate satellite infrastructure since they're web only. Examples of this include DAZN, 11 Sports, and I'm sure there are many others. So let's talk a bit about IP video transport and what it can do. IP video transport allows the use of IP networks, and IP networks can be a vague term, but it generally means private connectivity, the public internet, or sometimes a mixture of both, to transport and deliver content. And this can be delivered still as, in the end, as some kind of traditional means, so handed off as picked up or handed off as SDI or ASI, even though the underlying transport has changed. And it uses some form of error correcting technology, and I'll discuss this in quite a bit of later, to guarantee reliability, because IP networks, the public internet in particular, sometimes even private connectivity can have its issues. And generally speaking, contribution is point to point, so venue to a single broadcaster or production facility. And primary distribution is point to multi-point. So this is usually getting a channel or sports from one place to many other takers around the world. And we can look at a great example of one of the pieces of primary distribution that we do with one of our partners, and that's the NFL in Europe. Nowadays, most European rights holders take NFL matches, I think up to 4, maybe even 5 concurrent matches at a time. What's interesting is this project takes advantage of a lot of IP technology. When feeds are delivered, there's actually also an encoder at every single taker. This encodes a return feed. It sends a feed into the cloud, where it's rendered into a cloud multi-viewer, as you can see on the right. This means that the people at the NFL, both at a technical level and a commercial level, can see what rights holders are doing with the content. And this has already reached a stage where the satellite feed isn't used anymore in Europe, except for the Super Bowl. And because, I'll talk about this more later, but because the NFL only happens for a few hours a week, the usage of cloud technology means that these multi-viewers can be spun up and spun down at will. And at each NFL site, each taker, there's a public internet is used, and that's using one or more ISPs at each site. And you can see that this technology has been used widely for NFL and other applications, used widely across Europe, Latin America, Asia, Australia in particular, to deliver high-value premium content. So if you wanted to move your broadcast operations to some form of IP delivery technology, how would you go about it? Well, there are 2 different approaches. There's either do-it-yourself or use a service provider. The do-it-yourself approach involves buying encode, decode hardware, setting up some form of connectivity, evaluating protocols and rolling it out, and sometimes building your own or finding some kind of control layer. And ideally, you'd want an approach that allows you to scale in the future. So you can add extra feeds at the touch of a button, and I'll talk a bit more about this later on a technical level. But you may just want someone to do it for you, and we have a lot of partners, and there are many companies, not just the 3 that shown below, Globecast, Media, Atmos, and Cerberus, who can do this for you. And they can do this fully as a managed service, so that with a fully staffed MCR and all the usual bells and whistles. And this means you can get the benefits of IP technology already without having to spend time doing it yourself. And there's 2 different approaches that are, one is right for the right person, right organization. So on the topic of IP and satellite, how can IP augment satellite? Well, the big hot topic, unsurprisingly at the moment, is COVID, where social distancing is required at many events. And this is leading to what's known as remote production. And again, I'll go into more technical detail later. But this is where all camera feeds are sent back over IP, and the content is produced in a socially distanced facility with a lot more safety. And then this was already a hot topic before COVID for commercial reasons, but there's now obviously critical operational reasons for doing this. Consumers are also demanding additional content, sometimes on their tablets, phones, etc., especially for sports. And it may not be cost effective to put all of this additional content on satellite. And so IP is a great way of getting this content to end users. One of the common approaches right now is for those who don't want to just don't want to replace the satellite just yet, is to start moving backup feeds onto satellite, where these backup feeds are operated at a reduced bit rate compared to usual. This requires reduced megahertz and thus reduced costs. And the main feed is then put on IP. And this allows end users to have the confidence of satellite, but also the benefits of IP, because they can do remote production, they can do high bit rate, high quality IP content delivery. And if there's a problem, go to the backup. And there's also now receivers such as ours, which can switch automatically between the 2. So this can be a totally automated process. And they can switch automatically in a way that provides little to no obvious effect to the end user. So let's look at some of the advantages that IP has over satellite. IP is inherently bidirectional. So I talked about the encoders doing reverse vision feeds, but there's an inherent bidirectional capability. There's things that can be collected, such as telemetry, camera control, etc., etc., etc. There's already a broad knowledge base of IT engineers, especially young people now. IP has proven security. We all use internet banking. Most of the transport technologies use bank-grade security. Most broadcast facilities have good connectivity from one or more providers. And if they don't, they at least have good quality internet access these days. IP itself is inherently amenable to remote working. As you've probably all seen, we've all had to sit at home and log in via VPNs to various bits of equipment. This isn't as easy with satellite as I kind of just explained at the beginning. And one of the sort of best ways that you can take advantage of IP is by using flexible encode and decode platforms. By using IP, you can take much more modern approaches to doing things. In particular, provisioning equipment with room to grow in the future. This means whenever you need to launch a new channel or launch a new service, you don't have to go and ship boxes around the world. You can provision equipment that's ready, unlicensed, and when you need it, sort of pay as you grow. With IP, you can also do some more interesting things where you can move licenses between devices anywhere around the world. So for example, if you had a bunch of sports matches on a Saturday, you could activate in the morning, deactivate in the evening, move them to the equipment for Sunday, and then activate them again. And again, these flexible decode platforms can switch automatically between satellite and IP. Another really important aspect of IP is the use of cloud. Cloud is really important because traditional broadcast infrastructure has to be provisioned for its peak. And as a result, lays idle most of the time. This is really, really inefficient usage of resources. But what the cloud allows you to do is spin up and spin down capabilities. So if I want to spin up, for example, an AWS Media Connect or Media Live transcoder, that's doable point and click operation when it's needed. I can spin up multi-viewers as well. So on the right, this is a cloud multi-viewer. It's spun up entirely on the cloud, in the cloud for the duration of that particular event in the US. And then it was spun down. And that meant a physical multi-viewer didn't have to be bought. It could be paid for the amount of time that it was used. Much more efficient use of resources. Cloud playout and cloud distribution is also reaching maturity for many applications. Remote production. So I think we should go into a bit more technical detail about what remote production is. And as I've kind of mentioned before, with COVID, remote production is a really hot topic. What it involves is sending all the feeds back to base and producing content nowadays in a much more socially distanced fashion. This in principle could be done on satellite, but very costly to send all these camera feeds back. IP networks are much more suited to this, and they also have a lower latency, which means much more interactive decisions can be made at base and communicated back. So if you wanted to do it yourself and move various parts of your infrastructure to IP, there are various different protocols out there for error recovery over the public internet. The public internet, as we've all seen when trying to watch videos online, is not perfect. There are issues, but there are protocols out there which can recover these errors, and some are free and some of them are not free. There's 3 of them on the right, probably the most well known. And it's particularly important that care is taken when selecting the right protocol, in particular if the protocol supports one or more ISPs, whether the end user equipment supports the protocol, what kind of management you get around the protocol. And this is one of the things that said service providers will do for you. But if you wanted to do it yourself, it's pretty important to figure out which protocol is right for you. So to conclude, IP technology can really be widely used to augment or replace satellite, and is already doing so today. In particular, in the COVID era, it allows for numerous business and operational benefits. By using flexible encoder and decoder platforms, you can really make the most of IP contribution in primary distribution technology. IP also allows for usage of cloud services. This allows for much more flexible and better usage of equipment, as peak doesn't have to be provisioned for. Services can be spun up and down as needed. But careful choice of protocol is needed to gain the maximum business and technical benefits.